Okay, so we just had some adventures with numbers of moles of various chemical species, and we'd give you the amount of species A and ask you to find the moles of species B. Well, those numbers of moles come from somewhere, and usually they come from what we're going to do now. If you can get a substance onto a scale and weigh it, get a mass in grams, you can use that to find the number of moles by doing this formula here, which says the number of moles is the mass in grams divided by something called the molar mass, which we can look up on our periodic table. For example, they give us 454 grams of gold. We can blip over to the periodic table and find gold. Here we are. And the number in the top right in bold is our molar mass. In this case, it's 196.97. That means for every 196.97 grams of gold that you've got 1 mole of gold. And our formula tells us, sorry, wrong way. Our molar mass is 196.97 grams per mole is the unit they use. It's unfortunate that this formula uses 2 of the letter M, but the little one is mass and the big one is molar mass. You'll get used to that pretty quickly. We use this thing a lot. So our number of moles here will be the mass, 454 grams, divided by the molar mass, 196.97. And punch the calculator. We get 2.30 moles. And whenever you say moles, try to say what it's moles of. In this case, it's gold. Either write the English word gold or write AU. Either one's fine. So that's the calculation we're going to be doing for every single one of these. The only real difference is you'll see later on it becomes a little bit more work to find the molar mass. We'll see what that means in a moment. In number 2, it's not really any more work. The molar mass is still pretty straightforward. You look up copper. Copper is right here, and its molar mass is 63.55. Jot that down. So the number of moles for copper will be the mass of copper, 11.2, they gave it to us, divided by its molar mass, 63.55. 0.176 moles of copper. Okay, in number 3 we get our first little complication. Sulfur is not just S, it's S8. Remember your polyatomics? That means it's made of 8 sulfur atoms. So when we go to the periodic table and we find sulfur, this number, 32.07, is for 1 sulfur atom, and we don't have that. We have 8 times that much. So the molar mass for sulfur is 8 times 32.07, which comes out to 256.56. Sulfur has a monster molar mass. And so its number of moles is still the mass we were given, 0.217, divided by the molar mass, 256.56. This is a small number divided by a big number, so the answer is going to be tiny. I get 0.000846. 0.000846 moles of sulfur. This is the same trick again. Remember what nitrogen is? The symbol is N, but nitrogen by itself isn't just N, it's N2. And that means its molar mass isn't just 14.01, it's 2 times this. Every atom is 1401, and we have a pair of them. So, for our molar mass, 2 times 1401 makes 2802 for our molar mass. Number of moles is mass divided by molar mass. calculator. Math is easy. What are we doing here? 7.277 should be it. 7.277 moles of nitrogen. Not too bad. And finally, or last one on this page anyway, carbon dioxide. Carbon dioxide is made of two different kinds of atoms, which means we're going to be adding together a couple molar masses. Carbon dioxide is made of a single carbon, whose molar mass is 12.01, and two oxygens. 2 times oxygen is 16.00, so two of them is 32.00. The total from the carbon and the two oxygens is 1, 0, 2 plus 2 is 4, 1 plus 3 is 4. 44.01 is our molar mass. So you have to add up the masses of every single atom in the thing. In this case, there were three, a carbon and two oxygens. And believe me, it gets worse. Number of moles is 800 grams divided by 4401 is going to be like 18 something. 18.2 is about right. 18.2 moles of carbon dioxide. All right. Here comes some more with increasingly hairy molar masses. Let's see if we can handle it. Potassium nitrate. Potassium's +1, nitrate's -1, so the formula for this is KNO3. I did that a little fast because we've had a lot of practice, and I suspect and hope that you're getting comfortable with these. So, if we're doing this thing's molar mass, we must add up 1 potassium, 1 nitrogen, and 3 oxygens, and all that together will make our molar mass. The potassium's 39.10. The nitrogen's 1401. A single oxygen is 16, so 3 of them is 48.00. So, 1, 1. 9 plus 4 is 13, plus 8 is 21, carry a 2. 2 plus 3 is 5, 6. 6 plus 4 is 10. So 101.11 is our molar mass. And once we have that, as usual, the actual mole calculation is a breeze. 33.4. I mean, it's not do it in your head breeze, but at least it's easy to set up. 0.330 would be about right for our number of moles. And remember to say it's moles of KNO3. Cobalt to chloride. Cobalt is CO, and they've told us the charge is +2. Chlorides are -1, so cobalt chloride would be, or this cobalt 2 chloride would be, whoops. I don't know where I got an O there. That's COCl2 would be our compound. For its molar mass, we need a single cobalt, and I don't know what cobalt is, but we can find it. It's 5893. 58.93. Chlorines are 35.45 each, which means 2 of them is 70.90. I've seen that enough to remember it. 3, 9 plus 9 is 18, carry a 1, 1 plus 8 is 9, 5 plus 7 is 12. So 129.83 is our molar mass, and our number of moles, assume you're getting used to this, is our mass divided by the molar mass we just found. 15.2 divided by 129.83, 0.117 moles of cobalt 2 chloride. I appreciate you hanging with me this long. I'll try to pick up the speed a little bit for the last ones, just because I assume by now you've kind of got the drill down and you just want to see if you're getting the same answers as me, maybe. Zinc sulfate, ZnSO4. Molar mass would be 1 zinc, which is 6541. Sorry, I'll try to write numbers that actually look like something. 65.41, that's a little bit better. Sulfur is 3207. We really do have just one atom of it this time. And oxygens are 16 each, so 4 of them is 64 on the nose. Total, 1 plus 7 is 8, 4 plus nothing is 4, 5 plus 2 is 7, plus 4 is 11, 1 plus 6 is 7, another 3 makes 10, 16. 161.48 is our molar mass. There is absolutely no need, by the way, to add these up old school like this. If you're using the calculator, wonderful. I trust you're getting the same answers that I am. If you're not, let me have it in the comments and I'll apologize and make repairs. 0.195 grams divided by 161.48. 0.00121 moles of, just to prove that you can, I'll write zinc sulfate in English instead of writing the formula. It's all good. Okay, titanium 4 carbonate. Titanium is Ti. They're telling us it has a +4 charge. Carbonates are CO3 2 minus. It'll take 2 carbonates to match the charge on a titanium, so our formula is TiCO3 2. 1 titanium, 2 carbonates. That means as far as atoms, we have 1 titanium, 2 carbons, because this 2 applies, and 6 oxygens, because this 2 applies again. So for our molar mass, the 1 titanium is 4787, according to the table. Carbons are 1201 each, so 2 of them is 2402. And oxygens are 16 each, so 6 of them would be 96 exactly. 7 plus 2 is 9, 8 plus nothing is 8, 7 plus 4 is 11, plus 6 is 17, carry a 1. 1 plus 4 is 5, 6, 7, and 7 plus 9 is 16. Mass is 126.0 divided by molar mass 167.89, and again we go to the calculator. 1.6, oh rats, decimal in the wrong place. 167.89. And we get 0.7505. Moles of titanium, rats, sorry. TiCO3 2. There we go. And finally, what do they end off with? Calcium phosphate. Calcium's got a +2 charge. Phosphate has a -3 charge. So we get to do that crossover thing, make them both 6s. Ca3PO4 2 would be our finished formula. And that means when we're doing our molar mass, we've got 3 calcium atoms, 2 phosphorus atoms, and 8 oxygens. 3 calciums will be 3 times 4008, which is 120.24. 2 phosphorus, I have to do with the calculator because I don't know what phosphorus is, 30.97. 2 times 30.97 is 61.94 for the phosphorus. 8 times 16 for the oxygens gives 128 exactly. And so we get, let's see, 1 plus 1, 2, 10, carry a 1. 3 plus 6 is 9, plus 2 is 11. 111 is 310, is that right? I think that may be right. I did enough of that in my head that I kind of don't trust it, so I'm going to just run it one more time. Kind of fast. Plus 2 times 30.97 plus 8 times 16. Yes, 310.18 is our molar mass. And once we have that, the last part is pretty easy. 310.18. Divide that out. And I get 0.0912 moles calcium phosphate. Can I fit it in? Just barely. All right, so pretty straightforward, I think. I hope you're getting used to it. We'll be doing this routinely for the rest of the course, so you'll see plenty of masses and plenty of molar masses. I hope you get comfortable with that. As always, if you're having any trouble, the instructor's there. Give them a call or send them an email, and they will be happy to sort it out for you.